Have you ever wondered how images are formed in front of the mirror? Let's find out! When an object is placed in front of the mirror, an image is formed. This image has its own qualitative characteristics such as location, orientation, size or magnification, and type. These qualitative characteristics can be determined by ray diagram. This is a technique to determine the direction and angle of light rays. But before we proceed, let us first define some terms and talk about law of reflection.
It states that the angle of incidence is equal to the angle of reflection. The angle of incidence is measured between the normal line and the incident ray, while the angle of reflection is measured between the normal line and the reflected ray. The resulting reflected image can be characterized according to image location, orientation, size, and type. The location of the image always depends on the location of the object. An image orientation can be upright if it is right side up and inverted if it is upside down. The size of the image may be reduced, enlarged, or same size with the object size. An image type may be real or virtual. The main difference lies in the way in which they are produced. A real image is formed when rays converge, whereas a virtual image is shown when rays only appear to diverge.
Now, let's talk about how light reflects in plane mirrors.
Reflection happens when light ray bounces off a surface. When light ray bounces off the surface of a plane mirror, an image will be formed. Consider this scenario. Imagine yourself looking at a bee above you in the mirror. As you can see, the image formed is always located at the same distance, upright and laterally inverted, same size, and virtual.
Now, what will happen if the surface of the mirror is not plane but rather curved? These are called curved mirrors. One practical example is your metal spoon. Try looking at your image on both sides of the spoon. What have you noticed?
This is a reflection on curved mirrors. A curved mirror is a reflecting surface that is a section of a sphere. There are two kinds of curved mirrors, concave and convex. A spoon is a kind of curved mirror with a concave side and a convex side. Concave mirrors can be seen on the inside of the sphere, and convex mirrors can be seen on the outside of the sphere. In order to determine the characteristics of image formed in curved mirrors, let us first identify its parts. Principal axis, a line passing through the exact center of a curved mirror. Center of curvature C, the point in the center of the sphere from which the mirror was sliced. Vertex V, the point on the mirror surface where the principal axis meets the mirror and is also the geometric center of the mirror. Focal point F, midway between the vertex and the center of curvature.
To determine the location, orientation, size, and type of images formed in curved mirrors, let us first discuss the four principal rays used in ray diagram.
PF ray, a ray of light parallel to the principal axis, is reflected passing through the principal focus F. FP ray, a ray of light passing through the focus F is reflected parallel to the principal axis. CC ray, a ray of light passing through or directed towards the center of curvature C, reflects back along its own path. V ray, a ray of light directed to the vertex, reflects at equal angle from the principal axis.
Now, let's talk about how to apply these four principal rays in locating the image using ray diagram.
From the object, draw the first ray, which is the PF ray. From the same point on the object, draw the second ray, which is the FP ray. Then the third ray, which is the CC ray. And lastly, the fourth ray, which is the V ray. The intersection of the four rays is the image point corresponding to the object point. For example, if you started diagramming from the tip of the arrow-shaped object, The intersection of the reflected rays is also the tip of the arrow-shaped image. Thus, you can determine completely the position and characteristics of the image. For a convex mirror, light rays diverge after reflection and converge from a point that seems to be behind the mirror, but the procedure for locating images is the same as for concave mirror. Now, let us determine the location, orientation, size, and type of images formed in curved mirrors. Suppose that the object is located at this distance, farther than or beyond the center of curvature C. Applying ray diagram, you will get this. The point in which the reflected ray meet is the tip of the reflected image. The location of the image is between C and F. The orientation is inverted, the size is reduced, and the type is real. Let us have this another example. The location of the image is at C, the orientation is inverted, the size is same, and the type is real. Example number 3. The image location is beyond C, the orientation is inverted, size is enlarged, and the type is real. Example number 4. No image is formed. Example number 5. The image location is behind the mirror, the orientation is upright, the size is enlarged, and the type is virtual. For convex mirrors, the images formed are always: the location is between V and F, the orientation is upright, the size is reduced, and the type is virtual. Here is the summary on the location, orientation, size, and type of images formed in curved mirrors.
Here's a quick recap.
The law of reflection states that the angle of incidence is equal to the angle of reflection. A plane mirror will always result in the same image characteristics regardless of object location. Image characteristics in concave mirrors depend on the object's location. On the other hand, convex mirrors will always produce the same image characteristics.